was just going to do a really quick review of domain and range. You'll start to remember it all when I do it, I'm sure. So let's just start with this is just the parent function of a quadratic. Oh, pretend it's perfect. It's not. That would be perfectly symmetrical if it was perfect. Which the parent function of all quadratics is y equals x squared. So the domain is how far left will this go and how far right. So this arrow is pointing obviously up, but we're really just concerned about how far left. So when we're doing domain, how far left? Well, it's going to negative infinity. And how far right? It's going to infinity because that arrowhead is pointed up, but also to the right. If I'm doing range, it's how far down to how far up. And it's at 0 is as far down as this graph is going to go. And it's actually touching 0. So it's going to be a bracket. And then the comma represents like everything in between to infinity. So infinities never have a bracket because infinity is an idea, not really a number. So when you get to infinity, it just goes on further. So you can't bracket it. But if it's got a parentheses on it, that means there's not an actual value there. So let's just real quick, let's just do a regular number line. So let's say I have -2 with an open circle, and then it's shaded, and this is 4 with a closed circle. So there's not actually a value at -2. It's just getting it's just all of this. So -1.999 has something, but at -2, there's nothing there. So that would be a parentheses, -2. The comma represents everything that's shaded in between, and then it would be 4 bracket. That's the domain of this right here. It doesn't really have a range because it's just right, exists right on that one line. Okay, so let me give you another one. So let's do the parent function of exponential growth. So it looks like this. It passes through the ordered pair 0, 1. Not that that matters because domain is just how far left and how far right. So the domain is negative infinity to positive infinity. And the range, this time, it has an asymptote. It's getting closer and closer and closer to 0, but it's never going to touch 0. So this one is parentheses 0, comma, infinity. So that, and by the way, P.S., this is what's called interval notation. I personally think it's the easier of the two notations. If you were going to write this same one in what we call set notation for the domain, now this one's pretty easy. They would say all real numbers, or they would do the double bar R to indicate all real numbers. But for range, they have to do that X is, range is Y, not X. Y is greater than or equal to 0. Which isn't too bad when you're using set notation. It's some of the funky ones are a pain when you use set notation. Like this one using set notation would be -2 is less than X, which is less than or equal to 4. If you're using like the other notation. So I don't know. That's a lot, probably more than you really need to know. But I'm going to give you, in just a second, I'll do one of the funky ones with rational expressions on a different video, and we'll do the domain and range of it.